It's okay. I'll make you a host.
Yeah.
Okay.
Right. Okay, that's good. So let's go to the problems. You have the number with you? I can just go there.
So the number, so the first question is 263.
Okay, 263. Ugly number, right?
Yeah.
Okay. Let me share. Okay. Okay, so ugly number, write a program to check whether the given number is an ugly number or the positive number, whose prime number whose prime number only include 2, 3, and 5, right? So basically you we try to find out the factors, right? So that's the point, right? So we kind of try to divide until the number is divisible by 2. Okay. So then the number is divisible by 3. Then we try to divide until the number is divisible by 5, right?
Yeah.
So once after that, if the number is not 1, right, then it has some other factors.
Yeah.
That's what it means. So if number is 1, then it is true. After this one, if it still has any other, if it's greater than 1, right, then it is still, it is not, it is divisible by 2, 3, 5, and some other number also, right? So that's the whole idea, right? So that's that one. Okay.
Yeah. So if let me just show you. So here, where was my? I'm not sure how to open that window. Let me just figure out.
Should I stop the screen?
I mean, your shared screen disappeared, but I'm not sure how to bring it back. Maybe I have to rejoin the meeting.
No, I think what happens is you do a alt tab, it will be in one of the screens. Stop it and share it again, maybe.
Oh, I see.
Okay. Multiple participants can see it. Okay. Can you now see it?
Yeah, now I can see your screen. Okay. So basically, that if statement on line 12 is not necessary, and you can just delete all the statement after line 12. You can delete them all, and I will tell you what to write.
But what if that number is we need to we need to find a positive number, right? So what if it's a negative number? Because given an int, right?
It doesn't matter for this. Actually, you don't even need to use the because how do I say it? I don't think you need to use the if statement on line 4 as well. Sorry, I have to pick up this phone.
Sure.
Yeah. Hello? Oh, okay. Do you mind give me 3 minutes? Just to pick up something. Okay.
Yeah, sure. Yeah.
Hello, Viji.
Yeah.
Yes, sorry for the waiting. We will extend the time. It's okay. So basically, so you don't need the first if statement because the number, if the number less than 1, and the number is always a positive number, because here is integer, right? As
so
you
integer is can be a negative number, right?
yeah,
It is not an unsigned integer, right?
Yeah, but if a negative number divide 2, if a negative number divide those numbers, so the negative number will never be 1, right? Eventually. Because only the number eventually is 1, you will return true, right? If the number is not 1, you will return false anyway, right?
Okay, so yeah, it will avoid these iterations. Yeah. Okay, so you had something to
so
show me, right?
you try remove line 4 and line 5, just remove them. Yeah.
Okay.
And also remove line 10 to line 13. Remove them all.
Okay.
And add a statement, return num is equals to return num equals equal sign, num equal like yeah, double equal, yeah, that's it. And submit it.
Okay, so it will
yeah.
So yeah, I understand. So this is like a it's like a conditional statement, right? Yeah.
Yes.
Yeah.
This will be a conditional statement, and
yeah, correct. Okay, what is the next problem?
So the next problem, let me check. The next problem is question 204.
Question 204, right? Okay. Count the number of prime number less than a non-negative number, right? So so basically you are trying to okay, so you go so number of prime number less than 10, right? For example, so you try to find out whether that number is okay. So basically for how many prime numbers are there, right? So we need to find out how many prime numbers are there less than a certain number, right? So initially you assume everything is a prime, right? You make it as a 1, right? You make it as 1 and try to find out whether that number is a prime or not, right? So basically the prime number, whether if it is going to be having a multiple other than that one, then it is a prime number, right? Okay, so if it's going to have more only 1 and 2, 1 and by itself, then it's a prime number. So that's what you are trying to do here. So yeah, so if it's a prime number, you just make it as a 0. Otherwise you just when you get a prime other than that, you just break it. That's what
Right. So do you know what's the name of this algorithm? Did you figure it out by yourself, or you checked some articles and stuff?
Yeah, there was one discussion in this. Okay, so it has moved past, right? I think that I used I went through that one before writing this one. Yeah.
Right.
So is there, it's a part of an algorithm?
Yeah, so if you click that discuss,
yeah,
there's a name called the state
oh,
of, yeah,
yeah.
that's the algorithm name. Yeah.
Okay.
Mhm.
Okay. 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 Let me.
Next question is 172.
Okay. Next question is 172.
Yeah.
Factorial of trailing zeros. Okay, so I think this we started last week. Could not complete it, right? So I kind of after I went there, just kind of figured it out. So there were like two methods, right? You compute the factorial and you divide by 10 to find out how many times it is divisible by 10, right? To count the number of trailing zeros. Okay, so that is one method, but it is like it is going to be like a very you got to compute the factorial, then you have to divide it by 10, right? So it is going to be very it is not a logarithmic time. So what we need to find out, so what we are trying to find out is, we are trying to find out if the number is divisible by 5. So then if it's divisible by 5, then so you have, so then if it's then you have 2 also there, right? 2 into 5 becomes 10, right? So number of time it is divisible by 5. So we are basically trying to find out number of 5 factors, right? So when you count the number of 5 factors, you will be able to find out number of trailing zeros. So that's the whole idea, right? So so this is yeah, so that's what it is, right? So when you try to divide by that number by 5, so basically we start from we increase by 5, increase that range by 5. So if you have like 10 with you, so you try to divide, I mean try to switch by step of 5 and try to find out number of divisor by 5. So that's the whole idea. Okay, so then you will be able to find out number of trailing zeros. Yeah.
So you get last time when we discussed it, so I told you, so the only thing we need to know is how many the only thing we need to know is the number of 5s, right? Because
exactly,
we have enough tools.
Exactly, enough tools. Yeah, correct. So there's many so basically if you find 5, you will have 2 there, right? Yeah.
And another thing is, can you explain to me about the line 6? Line 6 is for loop, what it did.
Basically it will it is trying to find out, it is going to find out so every number, right, every fifth number, it is to find out how many divisibles are there. So how many times it is divided by 5, right? That's what it is trying to find out, right? So basically 5, 10 5, 10 so if you take 5, it is divisible by 1 time, right? So 5, so there is a 2 there, so 5 into 2 becomes 1, right? Your number of trailing zero becomes 1. So if you take 10, it is divisible again by 5 into 2, right? So it has only one divisor, only one 0. So if you take 15, so 5 into 15. So but if you take 20, right, 20 is 5 into 4. Maybe 20 is not, 100 is an or 25, right? 25, there are two two, there will be two, by the time you get to that one, there will be two trailing zeros. Yeah, so that's what it is. Yeah.
Yeah. Okay. So what will be the I numbers? So what will be the value of I in this for loop? Can you go through that? So the first value of I is 5. So what's the second value?
Okay, second value will be 10.
And what's the third value?
15.
Okay, that's good. That's good. So you know this expression.
Yeah. So this is start, end, and step.
Yeah. True. Yeah. Okay. Now we go to next question. Question 28. Yeah.
No. I didn't do 28. No.
Not 28?
128 maybe?
Yes, that's the solution you sent me is question 28. So you said it there, but I'm not sure if that's the right number though.
Okay, it's missing number, right? It's
yeah,
not
it is missing number.
268.
Oh, 268, okay.
Yeah, actually missing number was quite easy.
Pardon?
Quite basically you try to they were trying to see what is the missing number, right?
Yes.
So basically you add this one and add the number from the okay. So there are, if you have an array of n distinct number, right, 0 to n, to find out if there is any missing number, right, you find n sum of n, right?
Yeah.
So and then minus what is there in your list, that will become your missing number. Yeah.
So basically you first get the sum, then you minus the total. So you first get the actual number. So you first get the actual total sum, then you get the expected
sum of what you have in the list.
Yeah.
And you subtract it. Yeah.
And you minus, then you get it. Yeah. Did you figure out this solution by yourself?
Yeah.
Nice. Good one. Yeah. That's good. So I believe we finished the first 4 of that mathematical topic. Yeah. Now let's check there are other mathematical topics. Let me just okay. So now go to question 3 to 6.
Given an integer n, return true if it is a power of 3, otherwise return false. Given in integer n, return true if it's a power of 3, otherwise return false. Okay. Okay, if it's a power of 3, otherwise it is return false. So basically its its factors should be only 3, right? That's what it means.
Yeah. Yes.
So it's the same kind of thing, right? So while n divides by 3 is equal to 0, n equal to n divided by, so n divided, it's 3, right? So that's it. So if return n, it's a power of 3, right? Yeah, n is equal to 1. That's all.
Try that. Yeah.
Okay, time exceeded, right? Okay. So in the only one test passed.
Yeah.
Okay, so it's a kind of it's a power of 3. So n divided by 3 integer return true if it's a power of 3, or if it's a so how else can I find 3 power x, right?
The reason is you missed the 2 if statement, and both of them are very important. Think what if statement you missed. So when you are solving problems, always think about the if statement first. Yeah.
If n divided by 3 is not equal to 0 first time itself, then return false. Trying to make it return it initially itself. Okay, so that's all, right? If it is not divided by 3, okay, so then you try to find out if they have any other factor, right? You said 3 if statement, right? So while it's not the thing. So you're trying to find out if it's divisible, if it's you're just avoiding the modulo operation. That's all, right? There's nothing. Let's see whether this executes. Then return true.
But the while statement, so the while statement, while n is less than 1, so only while n is less than 1, you will do this operation.
Yeah, basically it should be greater than 1, right? So otherwise greater than 3. 3 is divisible by greater than 2 because it's a power of 3. 1 still exceeds the time. Okay, so then this while loop is taking a long time.
Yeah. Because from your while statement, it doesn't make sense though. Because if I look at your while statement, I will only think while n is only less than 1, so the while statement will run. And if n is not less than 1, so the while statement will never run, and it will just go to return true. Or basically, if you give like a 21, it will pass, you know. If you give this algorithm 21, it will return true.
Yeah, correct. Yeah. Mod 3 should be there. Yeah, mod 3 equal to 0. So this is the right statement. N is equal to n3. How else can I find the power of 3? So can I use a, so divided by 3, right? So can I use a left shift?
What do you mean?
No, divided by 3, right? If it's divided by 3,
yeah.
Can I use, if I use a left shift by 3 instead, right?
Yeah, but why do you want to use that though?
So there is a 3 if statement missing. That's what you said, right?
No. So the only problem here is okay. So you did this while loop. It's okay.
But it is taking a long time. It is not a.
Yeah.
It is taking a long time, right?
Yeah.
So
I told you that. So the only problem
could you do
for your algorithm is
got recursion? Do it without any loop bar by recursion.
That's a follow-up. That's a follow-up. So don't worry about that. So basically, so the only problem of your algorithm is you missed the 2 if statements. So you just need to add 2 if statements that will pass. So think about what situation that you missed, what circumstances that you missed.
Okay. So 1 is if it's a negative, right? But it is n equal to 1. So is it a positive? Should we check for if it's a positive or negative?
You can check that. You can check that, but that doesn't matter. So positive and negative, if it's a negative number, it will always return false because eventually n will always be a negative number. So n will never be 1. So you will never return true. So basically it doesn't matter for you to check if it's negative or not. But it does matter if n is some numbers. So think about what those numbers will be.
N mod 3 is equal to 0. Initially itself you return n mod 2, right? Basically n mod 2 or n mod 3, 6. So 6 will not 9. Oh, I'm just trying to say 5. 6 return is equal to 0. Then return false. So you're removing all the positive number from it.
I think you are removing all the even number.
Yeah, even number from it, right? So 3, 9. Okay, 3, 9. Okay, 3 into 9. Yeah. So does it reduce the time? Okay.
You passed it. Okay. But do you know why you pass it by removing all the even numbers though?
Because we were reducing all the reducing the number of iteration it would go through, right? Because what if I take what if I have taken 3 to the power of x 3 to the power of x into 2, right? So yeah, so basically it will go till the end. It will try to multiply it until it gets 2, right? You are trying to avoid that, right?
Yeah.
So that is what even if you could do this one, right? If n mod 10 equal to 0, because okay, I think what I know, I think this was Okay, so basically it is 3, 9, 27, 3 into, so basically if that number ends with, so that's only for applicable for 9, something like that I remember reading, right?
So can you give me an exact number that without the if statement, it will return true, and with the if statement, it will return false?
Yeah, with the only with the if statement, right? 243. So 243, right? So then so 3, 9, 27, 3, 9, so it is repeating, right? 3, 9. So it's ending with 3, 9. So is it returning power of the first 100? Okay, 3, 9, 27, 3, 9, 3, 9, but is it always returning? Okay, how do I find that? Okay, power of 3. Okay, so 3, 9, 27, 3, 9, 27. Okay, so this is good, right? So it looks like it is 1, 3, 9, 1. So the last number, right? So it looks like that one. So if I have, so we can use that logic, right? So basically your last digit, right? Your last digit is 1, 3, 9, 7, right?
Yeah.
So it's 1, 1, 3, 9, 7. So that's that. Then it is divisible by 3 if your number.
Really? Are you sure? How about 37?
No, first thing is it should be divisible by 3, right? If it's not divisible by 3, then you are there itself your logic goes away, right? So
Yeah.
then you got at the second level you need to find out whether it is divisible by 1, I mean whether the last digit is 197. Okay, let's see if it works. Not divisible by 2, then return false. Then we'll see if it is if this works. How do I find the last digit? N divided by 3, right? N divided by 10. Will that work?
I'm not sure if that will work, but about your previous solution and
Okay. Previous solution we are eliminating all the even numbers, right? Okay.
yeah. But what I think is we don't need to eliminating all the even numbers.
Okay.
I think that was just a coincidence that it was passed. What we need to consider is only two numbers. So the first number is 0 and the second number is 1.
First number is 0 and second number is 1.
Yeah. So we only need to consider two numbers. So we only need to add the two if statements to your.
Okay, can you send me in the chat?
Yeah. Can you revert the code back to the previous solution? Okay, I will send you from the chat. So basically, you don't really need to eliminate all the numbers. So you just need to consider when n is 0 and when n is 1.
Okay. So basically you are just avoiding 0 and 1, right?
Yeah. Because the reasons, so the reason your solution takes a long time is because 0 mode any number.
Oh, any number will be 0, right? So it was going on an infinite loop.
Yeah. And another thing is, so you also need to consider when n is equals to 1, because when n is equals to 1, it will, actually, you don't really need to consider, because eventually it will just return n equals to 1 and it will return true. So I think you only need to consider n is equals to 0. So you can remove the second if statement, actually.
Yeah. Okay.
Try this solution.
Okay, actually in the other one we had power of 2, 3, right? In that also we need to add this statement.
What's a statement?
There was one statement where we found out whether it is an ugly number, right? There we need to add this statement.
Just run the code and see how it goes.
Okay.
Yeah.
Yeah.
So what statement you were talking about?
Okay, we did an ugly number here.
Even number and odd number, that statement.
Yeah.
But why do we need to consider that statement though?
Okay, 263, right?
That statement is good because it can reduce the time complexity.
No, it will, I mean, I'm just trying to say here, the number is 0, right? If they have given 0, then this go into an infinite loop. Here also we need, if num equal to 0, then return false.
Okay. True, but if you check the question, if you scroll down the question, there might be some solution. Let me take a look. So input is within, okay. So when number is 0, return false. True. Yeah, true.
Yeah, actually it can have like less than 1. Yeah.
Less than 1.
1 is typically an ugly number.
Yeah.
Yeah.
That's interesting because in this question, it didn't take a long time and it didn't take...
it all depends upon what the test cases they have, right?
Yeah. True. Yeah. Maybe they don't have that test case. Yeah.
Yeah.
Okay. So next question is a similar one.
Which one? Okay.
Let me take a look. Question 342.
Okay, this is a power of 2, right? It's a similar one.
Power of 4 should be.
Yeah, it's a similar one, right? Power of 4 is similar one.
Do that.
So if n equal to 0, return false. While n mod 4 equal to, actually these things, right? If it's okay, so it's 1 is equal to n divided by 4. It's actually the same thing.
Yeah. So now you know that how to solve questions like that.
Yeah.
It's exactly the same thing, right?
Yeah, exactly the same thing. Yeah.
So next time when you see power of some numbers or just do the same. So first add an if statement, then you just do the while loop, then return the number is equal to 1. Yeah. Okay. So the next question will be more interesting. Question 365.
So you are given 2 jugs with a capacity X and Y liters. Yeah. Infinite amount of water supply available. You need to determine whether it is possible to measure exactly Z liters using these 2 jugs. So you have only X and Y. So it should be basically Z should be equal to some m into X plus Y into basically n into Y. So basically it should be it should be some X multiples plus Y multiple. So then only you will be able to measure it, right? So you are given 2 jugs with a capacity of X and Y liter. There is an infinite amount of water supply available. You need to determine whether it is possible to exactly measure Z using these 2 jugs, right? So basically you need to divide Z while Z equal to 0, less than 0.
Yeah.
So no, less than so basically you have to find out something like this, right? So you got to see whether Z is divided by mx plus ny. So how do I get that mx plus ny, right? So x is equal to 3, y is equal to 5, z is equal to 4, right? How are they getting that? So 3 plus 5, right? How do they get z? 4 then? This is a statement. So they have to do like half half of 2. Okay, fill any jugs completely with water. Operations allowed. Okay, fill any jug completely with water. Okay, so you can allow with completely with water. Empty any jugs. Pour water from one jug into another till another jug is completely full. Okay, so these are the water. So then if it's 3, 5 and 4, so 4 is the one you need. So you have 3. So 3 you completely empty it, right? So you have 5. You empty 3 inside. So you're left with 2. 2. How do I make 1 then? Empty any of the jug. So you're left with 3 and 3. Okay. Water in this. Minus 1, 4. Empty any jug, right? So okay, I think you can do it, right? So you fill I don't know whether how I will be mathematically will be able to do it, but I can explain how I can do this one. 3, 5, right? So you take the jug x, pour it with 3 liters, then you pour it back into y. So y has 3, so x is empty. X is empty. X is equal to 0. X becomes empty. Then you pour x pour x3. and then you pour into x, right? So 3 plus it can only hold 2, right? So after this operation, x will have 1, right? Then you can, so then you have 1. Then you can add x is equal to 3 later, right? So whatever you got out, right? So you will have 4. So this is how you can measure.
How do you get y equals to 3 plus 2? Can you?
Because okay, let me just tell you here. Okay, so here, right, when you empty, so when you empty x, when you pour x into y, it can only hold 2. Remaining whatever will be 1 in the x. You already poured, you start with x, you pour water into x, right? You transfer it into y. Y can hold still 2. Okay. Second time you pour water into x and you pour it back into y. So it can only hold 2 there. So that left with x is equal to 1. So then you are able to measure 1 liter there in that x. So then you take it into another container, the x equal to 1, and then you pour water into x again, x equal to 3. So you're able to measure 4, right? So you're able to measure it, but okay, 2 and 6, but you're not able to measure 5 in that.
So the question is asking you, how do you know that some number you can measure, some number you cannot measure?
Oh, okay, so that's a very interesting problem, right?
Yeah. Because so that's a good example that you showed me. Because think about that. So if you can measure that one letter, if you can measure one letter, then you can measure any number, right? Even I want you to measure like 5 or 6 or 7 or 8, you name it. So you just need to do the exact same thing with x and y.
X can measure, okay, x equal to 3 can measure 3, 6, 9, all 3 multiples, right? It can measure all 5 multiples. 5,
No. Just revert your code to that example that you showed me. I just gave you some idea about that. So the example you showed me, so you said that you can do some operation between x and y, then you can measure one letter of the water, right? From x, right? So you just need to do like do some operation here, and then you will get one letter of x.
Yeah, correct.
That's right. Yeah. So if you can measure one letter of x, does that mean you can measure any letter? Because all those numbers like 3, 4, 5, 6, 7, 8, any number is just a multiplier of one letter, right? So once you can measure one letter, you can measure any number.
Yes, correct.
Yeah.
1,
So
4, 5, 6.
Yeah.
1, 4 you can measure, and you can measure
I cannot measure 2 or 3.
2, 3, everything, right? You have one measure, right?
Yeah. So I can measure everything, right? So how do you know? So basically, that's the idea I want to give you. So how do you know some number can measure everything, and some number can only measure even number? Some number can only measure odd number. Some number can only measure the power of 3 number. How do you know these things? That's the key to solve the problem.
Okay, basically we need to work on these two, right? So 5, can empty. First time, how many times of x can it hold, right? It can hold one, so y can hold 1.5 times of x. No, it can hold 1 point, so 1 of x for sure. Then after that, whatever is subtracted, if it returns 1, then it is right. So another case, so if in this case so 3, so 1 of x.
Hey, chess kids, this is Grandmaster Eugene.
Sorry, just some video. Okay, go ahead. Are you still there?
Yeah, I'm still there.
Yeah. You can go ahead now.
I think mx y minus mx equal to 1. So that's what we need to find out, right? So mx, the smaller number, right, minus y should be equal to 1. This one, if it comes to this somewhere, sometimes, right, then you can be able to measure anything. Because here it is 2 into 3 minus 5 equal to 1, 2 times. So, but if you take here, right, 1 into 2, so if this one, example 2, 1 into 2 minus c is not equal to 1. 2 into 2 minus 6 is not equal to 1. So 3 into 2 minus 6 is not equal to 1, but it becomes 0, right? We have to stop it here. Yeah. So basically 4 into 2 minus 6 becomes greater than 1. So this is a stopping condition. If it becomes greater than 0, then we need to stop. It will not be able to measure it. Right?
Yeah.
So,
but that's only the condition that it can measure everything, but it's not necessarily, well, we not necessarily need it to be able to measure everything, right? We just need it to be measure Z. This
Z, right?
Yeah.
Z, if x is equal to 1, it can measure anything, right?
Yeah. So no matter what the Z is, we can measure it.
Yeah.
But, we also need to consider the possibility that the number we can measure is not 1. It can be, it can be 2. It can be 4. Basically, if you look at example 1, if the number we can measure is 2, can we measure Z? Can we still measure it? We can still measure it, right? We just need to do the same thing twice. If the number is 4, we can still measure it. So we can just measure it in one go. And so basically, you have to think. So first you need to get what's the number we can measure. Then what do you need to know? Then what you need to know is if Z divides that number, we can get 0. I mean, if Z modules that number, we can get 0. If we can get 0, then we can measure Z. If we cannot get 0, we cannot measure Z. Do you know what I mean?
Can you tell me one more time? Z mod what?
Z mod the number. So for example, why if the number we can measure is 1, we can measure anything? It's because any number modules that module 1 is equals to 0, right?
Yeah.
Yeah. So basically we need to first get that number, and then we need to use z to mod that number.
Okay. So if you, okay, I see what you're saying, right?
Yeah.
Y minus X, right? So Z, mod Y minus X is equal to 0, then we will be able to measure anything, right? That's what you're trying to say.
Yeah. I mean, Z modules that Y minus X, I mean, the only part in your equation that is wrong is that Y minus X. That's not the case. That's not how we get what's the unit that we can measure. It's not Y minus X that's simple. Yeah, so you have to replace that Y minus X to something. So you have to think about that. Yeah.
Okay, so it should be, yeah, mx plus ny.
Mx plus ny.
So basically this is what it is, right? So when you are trying to say Z is equal to mx plus ny.
But that is Z, right? We don't want Z. That number is not Z. So yeah, of course, in your equation, Z mod that number will equals to 0 because that will be Z module Z itself, right? Because mx plus ny is equals to Z in your equation. So that equation is meaningless because Z module Z equals to 0 doesn't mean anything. Yeah. So what you need to do is think about what to replace that mx plus ny, because that's the key of this question.
Okay.
Yeah. It's not that simple. It's not that it is not y minus x or mx plus ny. It's more complicated. It's like there is a mathematical concept of this. Yeah.
Oh, there's a mathematical concept in this? Okay.
Yeah. So think about that. So basically, how do you get 1 in example 1? So when x is 3 and y is equals to 5, how do you get 1? What's the relationship between the number 1 you get and x and y, 3 and 5? What's the relationship between 3 and 5 and 1? How do you get 1 from 3 and 5?
Okay.
Yeah, think about that. Yeah.
Okay.
Yeah. Okay, so this question, so I have give you some idea, and now the so this session is coming to an end. So basically, I will leave this question and this idea to you, so for you to think about it.
Yeah.
And also I will. So this, I think, is the after this question, there's another mathematical question, which is 575. You can also take a look at that question.
Yeah, can you just ping me in that fire so that I have this number? Sure. And also give me like more problems.
Yeah, of course. So that's the last problem in my mathematical topic.
I also wanted to ask you if you could give me like problems in that array, hash table, these things also, right? So that we can start we can discuss it. Array, hash table. You can give me like Yeah, if there is anything doubt, I can ask you, but start, you can give me more problems so that we can
Yeah. Sure. Okay. So how about I give you some so we go to the topic. So the next topic will be how about the topic backtracing?
Yeah,
Are you familiar with backtracing? Because that's a very common topic in Leetcode.
Okay, no, I'm not come. I do, but I've not done problems in that. But I would try to learn it. Start learning it.
Okay.
Okay.
Okay. Then in that case, I will send you a list of questions about backtracing, and
Yeah.
then you think about it and try to solve it. But don't look at the answer, because
Sure.
just
Yeah,
try to figure it out.
And we will try to see in all the more frequent problems. So to finish it.
Backtracing is a problem with like a specific templates. Once you know this kind of problem, it will be very easy for you to solve them. But if you don't know, it's very complicated. It can be very complicated.
True. I wanted to, we have to see that pattern of the problem, right? Now we saw 2 pointers and we have math problems. So those two things we got. So my question is, so can I start solving this like more frequent problems, right? There's which are in the green, and I can send you the solution. Will you be able to take a look at it? That is
I will take a look at it when we are in the next session, because I'm quite busy, you know. But,
okay.
In the next session, I will take a look and we can discuss, and I will always give you the best solution, because sometimes so your code is not concise or something. I will always give you the best solution.
Okay, sure. Okay, so then you can send me the backtracking problem. I will try to solve 2 pointer problem. Then one session we can try to book it only for seeing those 2 pointer problem and math frequent problem, and we will start to go with it. Okay, so you can send me backtracking problem now.
And I will also send you the and I will also send you the record of this lesson.
Sure. Okay. So you send me backtracking problem from my end. I'll send you the solution of the backtracking problem, and I'll start solving the math and the 2 pointers frequent problem. I'll send it to you, but we will have one session to go through all those solutions.
Sure. Thanks. Okay.
Sure. Thank you. Yeah.
No worries. Talk to you soon. Have a good
day. Sure.